So good afternoon, good afternoon and all. So today we will go for a third session on his method. So as usual, in session 1 and session 2, the steps are same. Step 1 to determine the fixed end moments, compute the rotational factors. So this figure 1 indicates how to calculate the stiffness based on the support conditions. So already we have studied in first session and second session. So step 3, step 4, step 5 and step 6. So determine the final moments here in the last step. So here in the first and second, so we are considering the end supports are the simply supported or hinge support. But now we're talking about the overhanging case. If the continuous beam having the overhanging, so what the procedure and what the difference in calculation is there. So step 1, so again we have to determine the fixed end moments. So based on the type of the load, so we have to calculate the fixed end moments. So here determine the rotational factor. So BA, BC, CB and CD, we are considering the two joints B and C. So if you're considering the D joint also, so the K value for the overhanging case will be 0. So already we have studied. So here the third column, so we have to determine the K value, summation of K, and here directly we will consider the rotational factor is equal to minus half into K by summation of K. So addition of these two, should be equal to minus 0.5. And addition of these two should be minus 0.5. So be careful about while calculating these values. So if 0.23 and it is 0.26 in the decimals, so there will be a vary of the next answers. So here there will be a note. For member CD, the position of support D is assumed partially continuous. Therefore, the relative stiffness K for the member CD is 3 by 4 I by L. Yeah, it's very important. Yeah, it's very important. 3 by 4 I by L. 3 by 4 I by L. So in the last cases, see here, C to D. So BA is I by L because of fixed. BC is I by L because of fixed. CB is I by L because continuous. CD is, so there will be a span here, but there is no any support. So this joint is called partially continuous. Partially continuous. CD is partially continuous. That's why, so it will become the K value will be considered as 3 by 4 I by L. 3 by 4 I by L. So there will be a value here. We have to calculate that. So keep in mind. So CD will be 3 by 4 I by L. So it is partially continuous. It's not a continuous. Only the overhanging case will be there. So we have to calculate the K value for that. K is 3 by 4 I by L. K is 3 by 4 I by L. So here next in the step 3, rotational contributions. We have to calculate the rotational contributions for the overhanging case. Before that, so what the internal balance is. So if any supports having the known moment. So here the AB we have to calculate, BA we have to calculate, BC we have to calculate, CB we have to calculate, CD we have to calculate, but DC with respect to the DE with respect to DE, so we have a moment here, the force into perpendicular distance 30 into 1.5. So what the direction is, based on the direction the sign will be indicated. So it is anti-clockwise, so it is minus 45. So already there will be a known moment, force into perpendicular distance, that will be minus 45. The direction is anti-clockwise, so it will be a minus. So it is not like that force into perpendicular, sir, this is a clockwise direction. It's not like that. Based on the direction, standard direction, it will be a anti-clockwise. So the minus will be there, minus 45. So if this is minus 45, as per the equilibrium condition, the summation of these two fixed end moments should be equal to 0. We know that all the conditions are equilibrium conditions. At the joint D, DE plus DC should be equal to 0. Then only the equilibrium condition will be satisfied. So what we will do, the fixed moment is 31.64. So adding or subtracting, we have to make the balance. Adding or subtracting this, subtracting, and we will get the plus 45. If it will be plus 45 minus 45, it will be 0. Then only the equilibrium condition will be satisfied. So adding plus 13.36, you will get plus 45. So this 13.36 is called the internal balance. When you have a balance, there will be a carryover. 50% of the balance is nothing but a carryover. That's the same sign, plus 6.68. Minus 52.73 plus 6.68, you will get minus 46.05. So 97.96, 73.47, 93.75, 93.75, 46.05, and this will be 45. These are the final fixed moments. If there will be internal balance, there is no need. There is no need to calculate anything here. So you will get the final moments, minus 45 and plus 45. So you have to calculate CD, CB, BC, BA. That's all. AB. So in the same procedure again. So based on the iterations, joint B. So we have to. Okay, M dash AB is 0. So M dash BA is rotational factor of BA, MFB plus far end moment. Again, initially the far end is 0, minus 20.28 is the MFB, summation of MFBA plus MFBC. So multiplied by minus 0.26. So you will get 5.27, 4.87. In the joint C, 4.87. See here, this will be the far end moment. 4.87 will be the far end moment. So you will get minus 17.87 and you will get minus 8.41. The first iteration will be completed. Come to the second iteration, the same values, only the far end value will be changed. So here, see here, M dash CB is the far end of joint B, M dash CB. So what is the value here? What is the value? 17.87. So this will be the far end of the joint B as well as joint C. Joint B as well as joint C. So next, so go to the third iteration, fourth iteration and fifth iteration. So after fourth and fifth iteration, we will get 10.33 as the same value in the fifth iteration. In the fifth iteration, third, fourth and fifth iteration. So compute with the fourth and fifth iteration. So that will be the final one. So fifth iteration, then final net moments, MAB is equal to MFAB plus 2M dash AB plus M dash BA. So this will be the standard equations where we have to calculate the final moments. 87.63, 94.14, see here, so 94.14 and here 93.80 in the based on some decimals. So we have to calculate the values. So similarly MCB, MCD, MDC and MDE, so you have to calculate all the values. The bending moment diagram, so take 87.63, then second 94.14, 64.36 straight line and 45. Join all the lines. It's very simple. Join all the lines, then it will be 0. Then next, go to the bending moment diagram. If there will be a point load, so it will be like this. If it is a UDL, so there will be a parabolic. Again it will be a point load, so it will be a point load. So enough. So this is the bending moment diagram. First you have to draw the end moments, then you have to go with the next moment. So how to calculate the shear force diagram? So how to calculate the shear force? See, that's the same procedure where we have to calculate the reaction at B, reaction at A, reaction at B, reaction at C and reaction at D. So this is your shear force diagram, 56.21. Then there will be a point load, take the straight line. So what is the point load you have to check? So that point load minus of 56.21, you will get 83.79. maybe 80 minus 56.21, you will get 43.79. So straight line. Then check what is the RB value. RB minus of 43.7, so we will get this height 118.45. Then next take the triangle here. The total load of BC minus of 118.45, you will get 106.55. Maybe 40, maybe 45 into 5, I think 225. So 118.45 minus of 225, you will get 106.5. So next calculate the RC minus of 106.55, you will get 61.09. Take the straight line. So check what is the load here, maybe 90 minus of 61.09, so we will get 28.91. Take the straight line and take the straight line. RD minus 28.91, you will get 30 here. Just join it. So this will be the procedure how to draw the shear force diagram. Thank you one and all. So again, I will tell you the MCQs, multiple choice questions, are attached with this. So solve those questions. Thank you.